In section 4.4, we're going to introduce the topic of direct and inverse variations. All right, so when you're looking at two different values, let's say how much you eat and how much you weigh. As you increase the amount you eat, your weight is going to go up. As you decrease the amount you eat, your weight will go down. This would be what we call a direct variation. As one value goes up, the other value also goes up. There's a direct link between the two variables. Now, if the other condition exists, that's called an inverse variation. Like, let's talk about comparing the number of pets you have compared to the amount of income you get to spend, disposable income. So you have a lot of pets, your extra disposable income goes down because you're spending all this money on vet bills and food and medicine and everything. So the more pets you have, the less money you can spend on other things. The fewer pets you have, the more disposable income you have, like for eating out and for other things. This would be called an inverse variation. As one quantity goes up, the other one goes down. As one quantity goes down, the other one goes up. These are the two type of variations we're going to be looking at. Direct variation, let's say it was calories, or I should say your pounds, your weight, we're going to multiply by this constant, k. You multiply by k with a direct variation. With an inverse variation, let's say, so this is income, we're going to divide by the number of pets. K divided by P. In inverse variation, K is divided by a variable. Direct variation, K is multiplied by a variable. All right, so let's start. For each problem, the game plan is to use the information to write an equation of variation. The information provided will allow you to find the value for K. Then you rewrite the equation using your value for K. So it's basically a three-step process. One, you write the general equation, either multiplying K by a number or dividing K by a number, depending on the type of variation. Step two, you find K. So they're going to have to give you enough information so that you can find what K, that constant is K. And then the third step, you replace K with its value in the first equation, and now you're ready to solve the question they really asked. All right, so ultraviolet light index is a measure of how intense the sun rays are at a given time. The UV index would be low on a cloudy day and high on a sunny day. All right, so the time it takes to get a sunburn. Okay, so as the UV index goes up, the time it takes to get a sunburn is going to go down. Right? The higher the UV index, the sunnier it is, the faster you're going to be able to get a suntan. So this definitely represents an inverse variation. The time it takes to get a sunburn varies inversely to the UV rays. All right, so let's write a general equation. Time to get a sunburn varies inversely. We're going to divide K. T would be time to get a sunburn. U would be the UV ray, the UV level. T is time to get a burn. U is the actual UV level. So this is a general inverse variation equation. So they're going to give us enough information so that we can find K, which is going to be a constant, and then we'll rewrite this equation. We won't use K, we'll use whatever the value of K is. So if the time varies inversely with the UV rays here, according to US News Online Consumer Tips, a UV rating of 6, an average person gets a sunburn in 15 minutes. We're going to use that to find K. Time is 15 minutes when the UV ray level is 6. All right, so let's find K. Let's multiply both sides by 6. And we get that this constant K is going to equal 90. So we're going to use this fact to find the constant of variation, and now we're going to rewrite our equation, but we're not going to put K, we're going to put U. I'm sorry, we're not going to put K, we're going to put 90. 90 is what K is equal to. So how long would it take to get a sunburn if the UV ray is 8.5? Time is going to be 90 divided by 8.5. So the time in minutes is going to take, doing that on your calculator, in 10.6 minutes you'll start getting a sunburn. Or you'll get a sunburn in 10.6 minutes. The higher the UV rays level, the shorter the time it takes to get a sunburn. All right, let's look at this next example. The amount of newsprint used by a newspaper varies how? As the number of people, so the amount of paper they need. The amount of paper that a newspaper company needs, well, varies to the number of people reading the paper. Okay, so as the number of people reading the paper increases, the amount of paper they will need increases. If the number of people reading the newspaper decreases, the amount of paper they need will decrease. This is a direct variation. The amount of paper used varies directly as the number of people reading the newspaper based on their circulation. All right, so we'll say N is the amount of newspaper they'll need, and that's going to vary directly with the number of people reading the newspaper. That is my general direct variation equation. So now they're going to give us a scenario where I can find what K is, and then I'm going to rewrite this equation. I'm not going to use K, I'm going to use K's value. So according to this association, the newsprint needed to supply the amount needs of 1,000 people is 34,800 kilograms. So we need 34,800 kilograms for 1,000 people. That's enough to find K. So let's get K by itself. Let's divide by 1,000. And so K is going to equal 34. This is 34,800, 34.8. So now that we know what K is, we can come over here and say the amount of paper, the newspaper that they'll need is 34.8 times the number of people reading the newspaper. So now I can answer this question. How many kilograms would be needed to supply Tampa, that has a population of 353,000? How much newsprint are we going to need? This is my constant. And rather than 1,000 people, there are 353,000 people. All right, so the amount in kilograms for Tampa is going to be 12,284,400 kilograms. So 12,284,400 kilograms. All right. That's kind of a weird number to be looking at. That's why they ask us, how much is that in pounds? So 12,284,400 kilograms. We want to convert kilograms to pounds. So we're going to need a fraction with kilograms in the denominator and pounds in the numerator. And there are 2.2 pounds in 1 kilogram. All right, so let's multiply across. Our kilograms cancel, and we're going to get 25,680 pounds of paper are needed for a city with 353,000 people reading our newspaper.